In this video, I'm going to give you further examples on how to use the binomial theorem to continue to expand polynomials or find specific coefficients in individual binomial expansions or in the product of two binomial expansions. For the first example, let's consider the opposite case when you are given the expansion and you are asked to give the value of the total of the expression. In this case, you don't want to calculate each of these values and then add them together. You want to avoid doing that extra work. So you need to find a creative way to do this. And if you look at the coefficients, we have 6, 0, 6, 1, 6, 2, etc. until 6, 6. That is an indication that we have an expansion of something to the power of 6. This a binomial to the power of 6. So what is the original binomial? We can see from the sum that 1/3 is in powers that are decreasing. So 1/3 to the power of 6, 1/3 to the power of 5, 1/3 to the power of 4, etc. until the very last term, 1/3 doesn't appear. So 1/3 has to be the first term of the binomial. Now the second term of the binomial should be similarly 2/3, because 2/3 to the power of 0, 2/3 to the power of 1, 2/3 to the power of 2, and then we're ending at 2/3 to the power of 6. So the last term of the binomial is 2/3. And if we add 2/3 plus 1/3, we get 3/3, which is equal to 1. This is the same as 1 power 6, and 1 power 6 is equal to 1. For our second expansion, let's consider a binomial where both terms in the binomial depend on the same variable x. Find the independent term of x in the expansion of x squared minus 1 over x to the power of 6. The term that is independent of x is the term with the power of x equal to 0. So what we want is we want to find the coefficient NCR that when we multiply it by x to the power of 2 to some power, n minus r, times minus 1 over x to the power of r, will only be a constant value with x to the power of 0. So we're going to have a coefficient with x power 0. So the first thing we want to do is to identify that n has to be 6. And so this is 6 CR, x power 2, 6 minus r, minus, and I'm going to write 1 over x as x to the power of minus 1, which to the power of r becomes minus r. And then this should be equal to some coefficient times x to the power of 0. So now I want to focus on the part of the x, the power of x. 6 to the power of 2 to the power of 6 minus r becomes 12 minus 2r. And I'm multiplying that by x to the power of minus r. Since we have the same base, it remains, and the exponents are added together. So 12 minus 2r minus r should be equal to x power 0. That means we can build an equation with the exponents where 12 minus 3r is equal to 0. And that means 12 is equal to 3r. So r is equal to 4. So what we want is a term in the expansion where r is equal to 4. So the term independent of x is C6, 4, x to the power of 2, 6 minus 4 is 2, times minus 1 over x to the power of 4. This is equal to 15 times x to the power of 4 times x to the power of minus 4, and this is equal to 15. For our third example, we have a product of two binomials. Find the first three terms in ascending orders of x in the expansion of 1 plus 3 to the power of 6 times 1 minus x to the power of 5. We want the terms in ascending powers of x. So we want the x power 0 term, or the constant term. We want the x power 1 term, and we want the x power 2 term. So those would be the three terms that we are looking for. To find the constant term, we need to find the constant term of the first binomial and multiply it by the constant term of the second binomial. So for the first binomial, the constant term is 1 to the power of 6. For the second term is 1 to the power of 5. So the constant term in the product is going to be the product of both of these terms, and that is 1. Now to get the term in x, or the term for x power 1, we need to consider two cases. The first case is from binomial number 1, we need the constant term, and from binomial number 2, we need the x term. The second case is from binomial number 1, we need the x term, and from binomial number 2, we need the constant term. And then, once we have these two cases, we are going to add them. So, let's consider the first case. From the first binomial, the constant term. We already have that, is 1 to the power of 6. Then we're going to multiply it by the x term in the second binomial. And that is the coefficient 5 combination 1 to the power of 4 minus x to the power of 1. Now to this we are going to add the second case, which is the x term in the first binomial, and that is 1 to the power of 5 and that is the combination of 6 and 1 to the power of 5 times 3x to the power of 1 times the constant term in the second binomial, which is 1 to the power of 5. One to the power of 6 is 1. 5 combination 1 is 5. 1 combination 4 is 1. Minus x to the power of 1 is minus 5. Minus x to the power of 1 is minus x. So the first term is minus 5x. Plus 6 combination 1 is 6. 1 to the power of 5 is 1. 3 to the power of x. 3 times x is 3. So we have 3x. And 1 to the power of 5 is 1. So 6 times 3 is 18. Minus 5 is 13. So the final answer for the second term that we want is 13x. For the third term, we want the term that contains x power 2, and that we can do in three different ways. The first way would be take the constant term from the first binomial and multiply it by the x squared term in the second binomial, and then do the opposite, the x squared term in the first binomial times the constant term in the second binomial. But here we have another option, and that is the x term in the first binomial multiplied by the x term in the second binomial. So here we have three cases. The first case is the constant term in the first binomial and the x squared term in the second binomial. We already know the constant term in the first binomial is 1 to the power of 6, and the x squared term in the second binomial is going to be 5 combination 2, 1 power 3 times minus x to the power of 2. Now, the second case, the x squared term in the first binomial times the constant term in the second binomial. So that is going to be the combination of 6 and 2, 1 to the power of 4 times 3x to the power of 2 times the constant term is 1 to the power of 5. Lastly, we have the x terms in both binomials. So that should be the term combination 5 and 1, 1 to the power of 4 minus x to the power of 1 times combination 6 and 1, 1 to the power of 5, 3x to the power of 1. The first term is equal to 10x squared. The second term is equal to 135x squared. And the third term equals to minus 90x squared. In total, this is going to be 55x squared. So, our final answer is going to be the first three terms in ascending powers of x are 1 plus 13x plus 55x squared. In our final example, we know the value of one of the terms and we are tasked to find the value of one of the coefficients. So in the expansion of px squared times 5 plus px to the power of 8, the coefficient of the term x power 6 is 3402. Find the value of p. So the first thing we have to do is identify what is going to be the term x to the power of 6. We are multiplying these parentheses with x squared, which means we are going to get the power of x power 6 by taking the power of x power 4 in the binomial expansion of 5 plus bx. So we're going to look for the term with x power 4 in 5 plus bx. Let's begin by writing what this term in the expansion is going to be. So we know it's going to be C8R 5 to some power px to another power that we know is going to be 4. So in that case, since the power of px has to be 4, then the power of 5 has to be 4 as well. And by extension, we know the value of r is also 4. Now what is this? So we can calculate the value of 8 combination 4, and that is equal to 70. 5 to the power of 4 is 625, and px to the power of 4 is p power 4 times x power 4. Now to get the total term, we need to multiply both sides by px squared, because that's the original polynomial that we should be looking at. And so with that, we get the x power 6 that we wanted. Now let's just focus not on the x's, but just on the numbers for the coefficients, now that everything is fixed to x to the power of 6. And we can create an equation for p. So this should be 70 times 625, that is 43,750, p power 5 and x power 6, but we're not writing it. And this should be equal to 3,402. So p power 5 should be 3,402 divided by 43,750. Now the fifth root of this fraction is equal to 3 over 5. So we found the value of p as 3 over 5.